G'day boys and girls, and how's my favorite class today? Today you will see a diagram of the sun's rays striking our planet Earth. You will see two distinct areas in the diagram, A and B, both showing the sun's rays. B shows the sun's rays striking a very small surface area on the planet. That is because the planet is round. Those rays are striking the center around the equator. They heat up a very small area and get it quite warm. In B, you see a polar region, and you see that the same number of sun's rays strike the planet over a larger surface area. The reason is twofold. Number one, because of the slant of the Earth, the rays have a larger area to heat. And number two, because of the intense angle that the sun's rays hit the planet, some glance off in our atmosphere. So there's really a lot less heating in the northern and southern polar regions than there is around the equator. Now, why am I telling you this? I'm telling you this because this causes uneven heating of the Earth. And it is uneven heating of the Earth that causes wind. If we had a planet Earth where there was no Coriolis effect, where there was not a rotating planet, all the winds on the planet would come in the northern hemisphere, would come from the North Pole down to the equator, and all the winds in the southern hemisphere would come from the South Pole towards the equator. So all the wind that we would get in North America would come from the north. But it's not like that. If the planet didn't spin, there would only be two large cells of atmospheric circulation, one in the northern hemisphere and one in the southern hemisphere. We know that's not the case. We know the Earth does spin. It spins and it creates the Coriolis effect, which is an effect on fluids, air and water, on planet Earth. Because the Earth spins, it creates three large cells of atmospheric circulation in the northern hemisphere and three in the southern hemisphere. Let's start at the equator. The equator's in the middle. You see Africa there on the left and South America on the right. And the equator goes through the two of those. Just north and just south of the equator are atmospheric cells of circulation discovered by a guy named Hadley, hence the name Hadley cells. Those Hadley cells create the wind patterns on the surface of our planet called the trade winds. Those trade winds are the strongest, most consistent winds on our planet. They blow along the surface of our planet in the direction that the two arrows show. Here and here, here and here. Okay? Those are the trade winds. In the northern reaches of our planet, we have polar cells. Those polar cells blow along the poles. They create polar easterlies. In between the polar cells and the Hadley cells, there's another atmospheric cell of circulation in the northern hemisphere and another atmospheric cell of circulation in the southern hemisphere, discovered by a guy named Farrell, hence the name the Farrell cells. The Farrell cells create the second most consistent wind patterns on our planet. They are the westerly winds. Now, in between both Hadley cells, there's an area with very little wind known as the doldrums. It's called an intertropical convergence zone. Not a lot of wind there. The same at the horse latitudes between the Farrell cells and the Hadley cells at about the mid-latitudes, around about 30 degrees. And that depends on winter or summer. The Earth is tilted, so the wind patterns kind of shift one way or the other. But don't worry about that. That's a little advanced for what we're doing. At around 30 degrees, there are the horse latitudes, which is another convergence zone, which, again, not a lot of air, or not a lot of wind. These are the drier regions. They're linked to the deserts in the northern hemisphere, around 30 degrees. What I really want you to understand for this course is I want you to understand that the trade winds blow along the surface of our planet, and they're the strongest, most consistent winds on our planet. and they blow in the direction shown on this diagram. Right above them, they are created by the Hadley cell. Right above them, with a convergence zone between the two called the horse latitudes, there's the Ferrel cell, and we have the westerly winds. The westerly winds are the winds that affect us on our island of Cape Breton. They're the second most strongest, second most consistent wind patterns on our planet. A lot to process there, boys and girls. Have a good day.